Some other kinds of general principles here about conceptual modeling. And again, this kind of goes back to a certain extent to what I was saying, that when we're adding associations, we don't necessarily want to add every association that exists in the world. First of all, even if this was for kind of general software development purposes, there are some associations that just aren't as important, that might, even though they exist in the world, aren't going to be important for our application. In the case of when we're doing this for the purpose of designing a database, there may be associations that exist in the world, but they're not something we need to keep track of in the database, and so we don't need to worry about those. And in general, the things that we do want to worry about are usually they're associations that imply some sort of enduring relationship that needs to be remembered, right? So there's an association between a sale and its line items, and this is something that almost certainly we want to remember that in the database. On the other hand, there's no reason for us to try to, well, maybe there could be a reason in some cases, but as far as I can think, in this particular case, I can't see any reason why we want to maintain an association between a sale and the sales manager who manages the department where the sale took place, or something like that. I suppose there is such an association, but it's just not something that's important. Also, we don't want to record an association between the point of sale terminal and customers' credit cards. Yeah, it's true that the credit cards are used in the point of sale terminal, so there's some, there is some association there, but that's not something that we need to remember. It may be that we record the credit card number as part of the sale, but we don't need to have a credit card class which is associated in a many-to-many association with point-of-sale terminals. We just don't need to keep track of that, most likely. Oh, yeah, okay, never mind. Again, when looking for associations, just like when we were looking at trying to identify concepts, it can be useful to kind of look at a list of categories of associations and try to think, are there any important associations in each of these categories that ought to be part of your model? So some of these kinds of associations, there are kind of physical part associations, like the point of sale terminal has a cash drawer as one of its parts, and maybe, well, that's probably something that's not important for that we wouldn't want to record, but that's an example of what we mean by a physical part. And in some cases, recording physical parts might be important. In this case, probably not. We also have logical parts, like a line item is a part of a sale. And unlike the point of sale terminal draw association, which we probably don't want as part of our model, this one, the association between line items and sales, we probably do want. Right? We've got other things that we might think about, like physical containment types of associations, that the point of sale terminal is contained in a store. Logical containment, that a description is contained in a catalog. Descriptions, like that a product specification describes an item. Oh, and again, by the way, I'm not contradicting myself here. I'm just giving an example of what a description association would look like. I'm not trying to say that this is one that should be included in our conceptual model for this, in this point of sale terminal example. We could also have sort of knows about or records kinds of associations, that the point of sale terminal records a sale. Maybe membership type associations, that a cashier is a member of a store. I suppose membership is pretty similar, sort of a subcategory of logical part. Ownership, associations, that the point of sale terminal is owned by the store. Subunits, again, this is sort of a special case of logical part, I suppose, where a department is a subunit of a store or a part of a store. We might have transactions, like that customers make payments, or that payments are made on sales. These are examples of transactional kind of associations. There could be communication associations, that the customer communicates with the cashier. Not likely that's going to play a part in our, in the conceptual model that we would be developing in this case, but again, just an example of that type of association. And again, so in terms of associations, again, I said this before, but we want to focus on enduring relationships rather than transient events. So the point of sale terminal accepts credit cards, but these are just kind of transient events. There's not a permanent association between a particular point of sale terminal and a particular credit card. And so that probably does not belong in our conceptual model. Another thing is that in the conceptual model, concepts are more important than associations. And if our goal is problem domain understanding, then too many associations can make it harder to understand the problem domain rather than improving your understanding of the problem domain. Right? If we draw association lines all over the place for every trivial association, whether it's important or not, we can end up with quite a mess and a diagram that's very hard to read and confusing. And in the case of conceptual modeling for the purpose of database design, there's not much point in recording associations that you don't need to store in the database. Right? If it's an association that doesn't need to be remembered, then, and that's our main purpose of constructing the model, then obviously that's going to affect how we choose to document associations. Some other things about associations. We want to try to avoid redundant and derivable associations unless they significantly improve your understanding of the domain. And I guess the kind of thing that I'm thinking about, I just want to kind of look at this example here, that we've got a conceptual model showing the associations between companies and employees and computers. So the company employs employees, and the company owns computers, and employees can be assigned to particular computers. And so I guess one of the questions is, do we need all of these associations? And in this case, I think the answer is yes, but if the model were even slightly different, the answer would be no. And here's kind of the way I'm thinking about this. So suppose we need to be able to find in our database a record of all of the computers that a company owns. Given a company, we should be able to find the records for all of its computers. So in this case, we have an association here, this owns association, which is exactly for that, right? So for each company, the company can own 0 or more computers. And when we store that association in the database, then we'll be able to easily find, given a company, we can find all of its computers, or given a computer, we can find what company it belongs to. That's what that association is for. It tells us which companies own which computers. But we might think about, is there another way we could do that without that association? So we know that the company employs employees, and if we're going to maintain that association in the database, then given a company, we'll be able to find all of the company's employees. And given an employee, we can find the computers that they've been assigned. Right? This says that each employee is assigned 0 or more computers. So the question is, do we need to keep track of, do we need this owns association to tell us which computers the company owns, or can we find it by going from the company to the employees and from the employees to the computers? Well, we can almost do it, except for one problem. The multiplicity in this direction is okay, right? This says that each employee can have 0 or more computers. In this direction, it's saying that for each computer, there are 0 or 1 employees. If it was just 1, we could get rid of this association, no problem. But because it's 0 or 1, what that means is that there are some computers that are not assigned to any employee. Right? There are some computers for which there are 0 employees assigned. So since the company owns some computers that are not assigned to any employees, that's why we need this association. Otherwise, we could get rid of it. It would be redundant. We might, when we're doing a design, want to record that association anyway for efficiency purposes, right? So it would be, if that's something, the kind of thing that we need to, the kind of information that we're going to need to commonly retrieve, we might want to maintain that association, even though it's not strictly necessary, again, for efficiency. Or we might decide that showing that explicitly that we're need to keep track of this association of which computers are owned by which companies, that making that explicit improves our, with the association line, improves our understanding of the problem domain. So it might be reasonable to keep it for that reason. But certainly if the multiplicity over here was different, we wouldn't need it. And likewise, if every employee was assigned a computer, rather than eliminating this association, we could instead keep that association and eliminate this one. Right? If every employee was assigned at least 1 computer, then we could find the company's employees by following these links, or these associations. Right? From the company, we can find all of its computers, and as long as every employee is assigned at least 1 of these computers, and we look up which computers are assigned to which employees, we'll eventually get all the employees. Again, because this is a 0 here, we can't do that. Okay. So if this multiplicity was exactly 1, then we'd have some decisions to make. And we'd have to decide, which gives the best understanding, and which of these is going to best document what we need to store in the database. Right? So we could keep all of these associations, or we could eliminate the employees association, or we could eliminate the owns association. Probably this one we probably need to keep no matter what. Right? If we need this information, we need to know which employees are assigned to which computers, then we definitely need this association. Nothing else is going to work. It might be that we know that an employee works for a company and the company owns a bunch of computers, but that's not going to tell us which employee is assigned to which computer. Or we could say that given an employee, we can find the computers that they own and then figure out what companies they work for. But again, we wouldn't know. Wait a second. Sorry, I did that wrong. So yeah, so that's just what we were saying before. So as long as every employee had at least 1 computer, then we could eliminate this one. But this one we need, right? There's no way to get rid of this if we need to know. It's not good enough to know to go from employee to all the computers that that employee could potentially have been assigned, or to go from employee to company to find all the computers that they've been assigned. We need this to know which employee goes to which computer. Okay. Just a few more things that I wanted to consider briefly. I want to think about aggregation and composition. So these are kind of part of associations. And so these are kind of a special type of association that designates that there's a part of type of association. And so in this example down here, we're saying that basically that a person is a part of a division, and a division is a part of a company. So aggregation, if we want to show aggregation, this sort of part of association, there's an open diamond at the end of the line. And for composition, there's a solid diamond. And the difference is that composition is a strong form of aggregation where the parts may belong to only one whole and whose existence depends on the whole. So the reason that these are different, because this one being composition means that a division can only be part of one company. Right? The same division can't belong to two different companies. And secondly, if the company goes out of business, the division goes away. Right? Because the division can't exist without the company. So that's composition. Aggregation is weaker than that. But it's the same kind of idea. This says that a person is part of a division, but the same person could belong to more than one division. So the same person could work in two different divisions in the same company, according to this model. And secondly, if the division goes away, the person doesn't, right? The person still exists without the division. So if your division goes away, all the people that belong to that division don't suddenly die, right? The people still exist. Okay, so those notations are available. However, at least to me, and other people may disagree or have their own opinions about this, but practically speaking, I think these notations are relatively useless, right? That this is a part of association as opposed to a more general association generally doesn't have any real consequence. It's hard to think of examples where it actually makes a difference. And the difference between composition and aggregation also, the fact of the matter is that if you just draw just a straight line between these two, or you draw a line with an open diamond at the end, or a line with a closed diamond at the end, how much does it change the way you understand the domain? Maybe it gives you a little more information. How important that is, I think, is pretty questionable. And when it comes time to actually move on to a design and an implementation, typically it's not going to make any difference. Right? As long as you know that association needs to be recorded and you know its multiplicities and so on, whether the association is a part of or a composition or an aggregation usually makes no difference. So anyway, again, this is an example, I guess, to my mind, of if for some reason it's important to record this, then fine. But generally, I don't think it is, and I think it's just making the diagram more complicated using notation that there's really not much point for. All right, I guess, I don't know if I needed to do this or not, but I just thought I'd just kind of review, different kinds of notation for multiplicities. Right, so just an asterisk or a star by itself means 0 or more. 0 ... star is another way of saying 0 or more. 0 dot dot n is another way of saying 0 or more. 1 dot dot star or 1 dot dot n means 1 or more. If we want a particular range, like at least 1 and at most 10, then we could use notation like 1 dot dot 10. If the multiplicity has to be an exact specific number, we can just give that number, like 5. We can also separate things with commas. This is pretty unusual, but if the multiplicity has to be exactly 3, exactly 5, or 10 or more, then we can just put those different multiplicities separated with commas. The other thing I guess also here wanted to point out is that I think it's important to not get confused between the multiplicity of an association between two classes and the number of associations between two classes, which are completely different things. So, and we can also have different, and we can have classes that are associated with themselves even. So the first example on here, we have an example where employee is associated with employee in a one-to-many association called supervisors. So this says that for each employee, or that each employee can supervise 0 or more other employees. Right. And so in this case, there's one association. Right? There's just one association that has this many-to-one multiplicity. So this is fairly common for a class to be associated with itself, but there are different roles, right? So at this end of the line, the one, and we could have put role names here. We could have put the role name supervisor on this end because it's the one supervisor who supervises many other employees. So we could have called this, given this a role supervisor and given the other end a role maybe worker. So we see that employees can play two different roles. They can play the role of supervisor or they can play the role of worker. And we have this association that each supervisor supervises 0 or more workers. Okay. Another example down here, and this is where I wanted to focus on the difference between the number of associations and the multiplicities of associations. So we might, for example, going back to this example again of an airline reservation system rather, we might want to associate each flight with the airport that it originates from and the airport that's its destination. So we have two different associations. With each flight is associated with two different airports. And one of these associations is a flies to association, and one's a flies from association. So for each flight flies from one airport, and each flight flies to, well, I guess maybe I was trying to be funny here, but probably we'd want 1. 0 or 1, I guess this means that maybe sometimes the flight crashes and never gets to the airport. So anyway. And then we have the multiplicities, right? So this says for each flight goes to 0 or 1 airports, and each flight flies from exactly 1 airport. And each airport can have many flights coming there, arriving from many different flights. And for each airport, there can be many flights that fly from there, and there can be also many flights that fly to there. So each of these associations has a multiplicity, right? And that means that there may be many links between airports and flights, right? Many individual links between a flight object and an airport object. That's what this multiplicity means. Even for each airport, even if we fix the airport, there can still be many links. But there are just two associations, right? Two distinct associations. And we can't eliminate one of these, right? I think a common mistake would be to say because of the multiplicity, you might think that, well, instead of having a flies to and a flies from, why don't I just draw one line between flight and airport and say that that flights and airports are associated with each other, and for each airport there can be many flights, and for each flight, two airports. Exactly, two airports. But that's not the right thing, because we would be losing information. Because just saying that this flight is associated with two different airports, but we don't know which one is the origin and which one's the destination, that's not the same information that we have in this model, where we have two separate associations. Right? So hopefully what I'm saying is clear. If not, maybe think about it a little bit, or maybe ask me some questions at another time. Okay. Just a few more things in terms of attributes. Attributes should be simple, pure data values, numbers, strings, dates, colors, things like that. Not a flight destination. Another important thing, and another common mistake, which relates to a common mistake, is that we want to relate concepts with associations, not with attributes. So we don't want to use attributes as foreign keys. And so just as an example, and I'll go back up to the slide here in a second, we're saying, an item does not have a UPC attribute. It has an association to product specs. Now let me just go back to the slide where and I guess the example that I'm giving, and we already, as we discussed earlier, this is not really a great model for conceptual design, for conceptual modeling. It's a good design model, but not a good conceptual model. But if this were the way we were going to actually implement things, and when we actually implement the database, that might be the way we do it, even though it's not the best conceptual model for understanding the problem. But even if this is what we're doing, it may be that the way we implement this association is by storing along with each item the UPC code of its product spec, so that given an item, we can find the correct product specification that goes with it. Right? That would be one way to implement this association. It's not the only way, but that's one way we could do it. So the point here, though, is that the way to document that the item is associated with a product specification is to draw an association line. And UPC code is not an attribute of an item. It might be stored with the item as a way of implementing the association, or it may not. And so that is the kind of decision that we don't even want to be thinking about right now. And we'll get to that later. So we have this kind of situation where in our relational database, we just have flat tables, and we can't really store in-memory pointers to other objects, so we've got some limitations. And we think about, well, how do we implement that association? And One way to do it would be by storing the UPC code with each item. Another way to do it would be to create a new table to record which items go with which product specifications, and so on. So anyway, I don't want to get into all that right now. We'll talk later about how we go from a UML or an ER model into a relational schema. Okay. Let me just go back to where we left off. Okay. Okay, so definitely do not want to use attributes as foreign keys, right? If you want to indicate that there's an association, just draw the association line. Give the association a name if you want. You can put role names if you want, but it's not appropriate at this stage of development to start doing this design work as to how you're going to implement the association. Inheritance, I don't think I have too much to say about, other than that, the idea is basically we're going to share common attributes and common associations, and we can develop inheritance or add inheritance to our model in two ways, either bottom up by noticing that some of our existing classes, concepts, have either associations or attributes in common, and then we can generalize those common aspects of existing classes to create a superclass and move those commonalities into the superclass where each subclass would inherit. The other way that inheritance gets added to these models is by noticing that there are specialized subclasses of some class that's in our model, and so we can then add subclasses to specialize. Okay, so just to kind of wrap up some of the key points here. Conceptual models are concerned with the problem domain, the real world, and not with software artifacts. UML class diagrams are very useful for modeling concepts and associations, as are ER diagrams. We want to try and do as good a job as we can in determining what are attributes and what are concepts, and not getting the two things mixed up. We want to bear in mind that concepts are more important than associations and should probably receive more attention when you're doing this modeling. We want to not include associations that are redundant or derivable from other associations unless it really improves your understanding of the problem domain. And finally, one last point, and this kind of goes to the kind of issue that I was talking about with composition and aggregation, although I don't necessarily want to pick on those things necessarily, but generally speaking, when you're doing UML modeling in particular, about 80% of modeling activities can be done using about 20% of UML's notation. So I guess the point here is don't feel compelled to use every feature just because it's there, right? And again, same thing goes, by the way, when you're writing code or doing anything. The point isn't to show off how well you know the notation, how well you know the language, to the point where you're writing code that nobody else can read because you're using such all these obscure language features or obscure notation that are rarely used, and that's not the point. The point isn't to demonstrate how well you know the notation. The point is to gain a good understanding of the problem domain. Okay, all right, that's it, I guess, for this topic. So I'll end it here.